Good morning, all of you.
Good morning, sir.
Good morning.
So I hope all of you write exam well. Yes.
Yes, sir.
Exam are important. వచ్చినాయా నేను పంపించిన దాంట్లోకి వెళ్ళి కొన్ని క్వశ్చన్స్. Okay. Sixth group in so tomorrow is the last. I gave important also. Okay.
Sir, voice is not clear.
So
Sir.
when the
Sir, your voice is not clear, sir.
ఇప్పుడు చూడండి ఓకేనా?
Yes, sir.
సో చూడండి, సో also today or tomorrow, maybe tomorrow is the last class. When exam start date 17th, third sem. Okay, so we're discussing about in block one inorganic chemistry, sixth A group elements, seventh A group elements, and zero group elements. Okay, zero group element means nothing but eighth A group elements. Okay, in last class, sixth A group elements are completed. Okay, na? Sixth A group elements are completed. Then next one, so a video link already available in YouTube. Video link available in YouTube. Go for video. Then zero group elements, block 3. So zero group, you know that. What are the zero group elements? Anyone? Soumya. Durga.
Sir, helium, krypton.
Glasses, sir.
Zero group elements.
Sir, helium, krypton, neon.
Okay, first one is helium, second one is neon, third one is argon, fourth one is krypton, fifth is xenon and radon. Okay, na? These are zero group elements. Okay, na? These are zero group elements. See, helium, neon, argon, krypton, xenon and radon. So these are the zero group elements. Okay. Why it is called zero group? Okay, na? It is a 8A group. In the periodic table, the place of zero, okay, na? This group is last at the end. In every period, these elements are at the end of the periodic table, and these are noble gases, also called are inert gas elements. Okay, na? Zero group elements, 8A group elements, noble gases are inert gas elements. Okay, na? These all are comes under the same helium, neon, argon, krypton, xenon and radon. Okay, na? So what are the objectives? Okay, na? What are the objectives for in this lesson? See, explain why zero group elements placed in the each period along okay, na? Long form of periodic table. Ante in every period, the zero group elements at the end of the periodic table. At the end of the periodic table in every period. Okay, na? Why it is placed at that position? We have to know in this lesson. And second point is, give the reason for their existence. Okay, na? The existence as monoatom gases at room temperature. Okay, na? So we are always writing as He and NAR. We are not writing He2. N2. Okay, na? They are existing only monoatomic gases at room temperature. Okay, na? Always. And why reason behind? And third one is state the main reason. State the main reason for their total chemical inactivity. Why they're inactive? Why they're inert? And why the gases are noble gases? Okay, na? Okay, state the main in this lesson. And fourth one is describe the isolation of individual gases from liquid air. Okay, now isolation. Isolation means, what is isolation? Anyone? Isolation means extraction. Okay, na? Extraction of zero group elements. Okay, na? Isolation means that extraction of zero group elements. Extraction of zero group elements from liquid air. From liquid air. Okay. Fifth one, state the principles in the separation of noble gases. So how the separation of noble gases is going? Oh, okay, by the fractional distillation and adsorption on charcoal. These are the two methods. These are the two methods for the separation of noble gases: fractional distillation and adsorption on charcoal. Very, very important one. Okay, the voice is clear, all of you?
Yes, sir.
Yes, sir.
Okay. So explain, and then one other objective is explain how the rare gases combine, with polar molecules like HCl and SO2. Okay, na? So these gases are combined with HCl and HO2. So how? Okay, na? It combined. So we know in this lesson. Then explain the clathrate compounds formation with quinol, and mention the uses of noble gases. Okay, now what are the applications? You know that in balloons, helium balloon, okay, now argon, and so you know that decoration bulbs, and you know that white plate boards untai kada, chusara? So shopping mall baita gaani, medicals baita gaani boards చేస్తారు, గుర్తుందా? Okay, so అటువంటి వాటిలో కూడా యూజ్ అంటే what are the noble gases are used? Okay, na? In what are the applications of noble gases? And this is the bonding in xenon fluorides. Okay, na? So these are the objectives we have to learn in this lesson. These are the objectives we have to learn in this lesson. Okay. Next one, see. So in last class, I already discussed this introduction and up to this completed. So we will show introduction. Okay, you know that helium, neon, argon, from this neon, argon, krypton, xenon, and radon consist the group of zero group elements. Okay, now they were not known at the time of classification of elements by Mendeleev. You know that. Okay, now the periodic table in the elements is introduced by Dmitry Mendeleev Ivanovich. Okay, now at the time of introducing a periodic table, they were not known zero group elements. Okay, these elements came only towards the end of 19th century. At the end of 19th century, in the early years, they were a separate group. Okay, now these zero group elements do not combine or do not form any compounds. Do not form any compound with other periodic table elements. So that's why these are placed in the separate group. What are they? Helium, neon, argon, krypton, xenon, and radon. Okay. See, according to they were placed in a separate group. Indicate their chemical inertness and zero valency. Why it is called zero group elements? The valency of helium, neon, argon, krypton, radon is zero. Okay, na helium, neon, argon, krypton, xenon is zero. Okay, na they are not known as He plus and He minus. The valency is only zero. That's why it is called zero group elements. Okay. So all of you. So tell me yes or no.
Sir, your voice is not good, sir.
So from now,
Still having some disturbance, sir.
there is no disturbance. Okay, na it is a single, maybe fluctuating signal, maybe. Okay, the signal is fluctuating. Okay, see the zero group is, see the what is the best reason. Okay na, the chemical inertness. Okay na, chemical inertness and zero valency, it is separated group and placed at the end of the periodic table, placed at the end of the periodic table in every period. Okay, the elements are placed at right hand extreme of the periodic table after halogens. After halogen, you know that these are S block and these are P block, these are D block, these two are F block. S, P, D, and F. Okay, now this is 1, 2, third group, 4th A, 5th A, 6th A, 7th A, 8th A. 8th A is nothing but zero group elements. These are the halogens. These are the halogens. Okay. Next, you know that general configuration of zero group elements. Configuration of zero group elements is NS2 NP NP6. NS2 NP6. NS2 means there are 2 electrons in s orbital. NP6 means completely filled 6 electrons in p orbital. Okay, now 6 electrons completely filled in. These are general configuration zero group. This position is fitting in the bridges gap between most electronegative halogens. In the periodic table, the halogens are most electronegative. So highest electronegative atom is in halogens. In periodic table also, in periodic table it is fluorine. Okay, na? It is fluorine. You know that halogens are fluorine, chlorine, and bromine, iodine. Okay, na? Discussing about this chapter in last class, you see the video. Okay, na? Fluorine, chlorine, bromine, iodine. So these are the 4.0 highest electronegativity value. Highest electronegativity value in periodic table is fluorine. Okay, na? That's why they placed adjacent of halogen group. See this point. This position is fitting in the bridges gap between most electronegative halogens, which is group 7, and most electropositive alkali metal, group 1. Okay, na? Group 1. With the determination of their atomic number and electronic configuration were found as NS2 NP6. NS2 NP6. But only helium is 1s2. Only helium is 1s2. Remaining all are comes NS2 NP6. NS2 NP6. If the 2s2 2p6, 3s2 3p6, 4s2 4p6, 5s2 5p6, 6s2 6p6, like this. Okay, na? Except only helium is like number 2 atomic. Okay, na? Atomic number 2. So this is 1s2 only. Okay. So these are the introduction of occurrence. Occurrence means anyone? What is occurrence? Just react. Occurrence means availability in earth crust. Okay, na? Availability in earth crust. So these are not available in earth crust. These are available in atmosphere air. Okay, na? Atmospheric air. See, as indicated, see this indicated. See this one. As indicated earlier, the elements helium, neon, argon, krypton, xenon, and radon form a group 0 of the periodic table, with the exception of radon. Okay, na? Ememuna cheppandi sir? Helium, neon, argon, krypton, xenon, and radon. Except radon, all helium, argon, all in atmosphere. Okay, the extent and less than 1% sir. In atmosphere yellow, you know that in atmosphere 100%, you can 78% nitrogen, nitrogen, 20.9% oxygen, okay, remaining 0.03% CO2, and remaining less than 1%. Remaining all the elements available in atmospheric air. You know that nitrogen is 78%, Oxygen is 20.9, nearly 21%. And remaining all 1%, okay, CO2 and the noble gases, and as well as moisture, okay, now see the occurrence. See, with the exception of radon, all occur in atmospheric air to small extent, about 1%. 1% low, argon itself, only 0.9%. Okay, na 0.9% is argon available, 0.9%, and radon is radioactive element. Radon is radioactive element. Radioactive element. These are the occurrence of elements. Okay. Next, isolation. This is important. You take screenshot. These are the important. Okay, na in your examination point of view, all of you take screenshot.
Sir, this one, sir, isolation of the noble gases from atmosphere.
Isolation of the noble gases from atmosphere. This is important. This repeated question in this lesson. Okay, now there are asked only isolation and uses of noble gases and xenon fluorides. Okay, now xenon fluorides structure and geometry. Okay, now so there are two methods for the isolation of noble gases from atmospheric air. First one is fractionation. Okay, now fractionation and fractional distillation, fractionation of liquid air, and second one is adsorption on charcoal. So this is one is next one. Method 2 is adsorption on charcoal. Isolation is taking place. See, only noble gases, the only source of noble gases except radon. Okay, na except radon in the atmosphere. Okay, radon kaakunda మిగతా అన్ని కూడా మనకు atmospheric air లోనే available గా ఉంటాయి. So chemical elements, isolation and separation of chemical elements or compounds, chemical properties. Okay, na so you know that the chemical property is different. The isolation also very easy. Okay, na so for example, some examples are there. Okay, na kerosene, water. So they do not mix because the kerosene is non-polar and water is polar. The separation is also easy like that. Okay, na the chemical properties also, and water and kerosene. Okay, na polar, non-polar, and boiling points. Okay, now boiling points are melting points. The different boiling point. So the occurrence also and isolation also is chemical properties. See, but since the noble gases are chemically inert, so the noble gases are chemically inert. All these are chemical properties are equal. Okay, now chemically inert. They do not form any compounds. So they are chemically inert. So their isolation is on their physical properties. Okay, na physical properties isolation cheyali because these all are chemically inert. The physical properties based on mass difference. You know, okay, na mass difference have therefore they've been employed for the purpose. Okay, na mass difference. Okay, na and endukante helium యొక్క మాస్ డిఫరెంట్ ఉంటుంది, హీలియం మాస్, నియాన్ మాస్ డిఫరెంట్ ఉంటుంది. ఓకేనా, ఆర్గాన్ డిఫరెంట్ ఉంటుంది, xenon ఉంటుంది, క్రిప్టాన్, దే ఆర్ డిఫరెంట్ మాస్. దీస్ ఆర్ ద ఫిజికల్ ప్రాపర్టీస్, బట్ దీస్ ఆల్ ఆర్ కెమికల్లీ ఇనర్ట్. ఓకే, సో ఇన్ ద atmosphere, the noble gases are mixed with oxygen and nitrogen. Okay, na the atmosphere, you know that I already tell. Okay, na so in atmospheric air, what are the gases available? 78% nitrogen, 21% oxygen, and water vapor also. Okay, na moisture, water vapor, and carbon dioxide. Okay, na in atmospheric air, nitrogen is there, and oxygen is there, and CO2 is there, and water vapor also available in atmospheric air. From all this mixture, we can isolate only noble gases. Okay, na? That's why these are the remove. Okay, na? So see, so how it is removed? See this. The water vapor and carbon dioxide first removed from the air. First removed from the air by suitable chemical method. By suitable chemical method. The air that purified is liquefied and fractionated. Okay, na? So and then purified and fractionated. In another method, oxygen and nitrogen also removed by chemical methods. Okay, chemical methods. And residual gases, mixture of noble gases, is subjected to selective adsorption on charcoal in a certain low temperature, followed by desorption in high temperature. Adsorption and desorption. Adsorption means, okay, now applying on the surface. Desorption means removing the surface. Applying on the surface, adsorption, and desorption is removing. Okay, now so adsorption on low temperature, desorption by temperature is remove from the surface. Okay, so these methods, okay, now these methods is one by one. We can isolate the noble gases. We can isolate the noble gases. So all of you understand? Soumya, Tasmiya, Anyum. Just respond yes sir, no sir, okay, understanding or not.
Yes, sir.
So the remaining are silent. See, you take the screenshot, this one. See, the boiling, see this, the boiling point, okay, na? Boiling point of atmosphere gases is different. See, boiling point of helium is minus 268.9 degrees, and neon is minus 246. Nitrogen is minus 195. Argon is 185. Oxygen is 183. Krypton is helium, neon, nitrogen, argon. They are different. They are different atmosphere. That's why, based on the physical properties, isolation of noble gases is very easy. Okay, na? When comparison to chemical properties, because the chemical properties of zero group elements are inert, chemically inert. Okay, that's why this based on only physical properties. Physical properties know the boiling point, melting point, and so etc. Okay, see, simple method and important for examination point of view. Adsorption and charcoal. Take the screenshot. This one also. Okay, na? This method, adsorption and charcoal. In last time, this question is, okay, na? And one of the papers, okay, na? In last time, okay. See the separation of noble gases. See the line, this line. The separation of noble gases of the atmosphere by adsorption technique. Based on the fact that charcoal adsorbs gases. Okay, na? Charcoal, what is the charcoal means? Carbon. Charcoal is nothing but carbon. Okay, na? So based on the fact of charcoal absorb gases with different degrees of tenacity, depending on their atomic masses. So every has different atomic mass, atomic number, and atomic mass also different. If helium is 2, atomic mass is 4, and neon is 10, atomic mass is 20. Okay, like this. So atomic number and atomic mass is different for every element, every zero group element. So the differs and degrees of tenacity depending on their atomic masses. The higher gases are adsorbed. Okay, na? Higher. The lighter ante, okay, na? Lighter gases are adsorbed with difficulty, and they're also dissolved with great ease. They absorbed difficulty and they dissolved easily. What are the gases? Lighter gases. Okay, the heavier gases are strongly absorbed. At a given temperature. But absorbed gases can be dissolved by raising the temperature. Okay, na? Dissolve cheyalante em cheyali? Temperature ni raising cheyali. Okay, na? Temperature will raise. Okay, na? This is the method, adsorption on charcoal. See, After the removal of, first, see the method. After the removal of carbon dioxide and water vapor, oxygen and nitrogen are also removed by chemical methods. These retrieval gases are mixed contain the noble gases. Okay, now you know that I repeatedly telling N2, O2, CO2 plus water vapor. So these all are removed. Okay, now these all are removed, and the residual means remaining. What are the noble gases only? Noble gases. The remaining mixture contain noble gases. It is passed into Dewar flask. This is one important Dewar method. Okay, now how the noble gases are isolated in Dewar process. Okay, now how the noble gas is isolated from Dewar process. Dewar process. Okay, now this is a question, important question. And Dewar flask containing activated coconut charcoal. Activated coconut charcoal cooled at minus 190 degrees. This is all the mirror of, okay, all passed through Dewar flask and activated, okay, na, containing activated coconut charcoal cooled at minus 190 degrees. The all noble gases are cooled at minus 190 degrees in contact with the gas mixture of few hours for saturation. Okay, na, the mixture, okay, na, the charcoal is contact with noble gases, with saturation, okay, with saturation for few hours. At 190 degrees, at minus 190 degrees, charcoal absorbs all the noble gases. Charcoal absorbs all the noble gases at 190 degrees. Okay. See, the unabsorbed gases are pumped out. Okay, now, so we are taking as helium, neon, argon, krypton, and xenon. Okay, now, so these are all the 5 noble gases are passed through a Dewar flask. Okay, now, the Dewar flask containing activated coconut charcoal, and these mixtures are cooled at minus 190 degrees. Okay, now, so because the activated charcoal is saturation with all the noble gases, after few hours, all the noble gases are absorbed on the charcoal, and unabsorbed gases are pumped out to the out. Okay, now pumped out. Then the flask then gradually warmed up. Okay, now the flask gradually warmed up to minus 100 degrees centigrade, minus 190 to minus 100 degrees centigrade. When helium and neon, the lighter numbers get dissolved first. ఎప్పుడైతే ఫస్ట్ ఏది వెళ్ళిపోతుంది, హీలియం అనేది నియాన్ అనేది. హీలియం ఈస్ లైటర్ ఎలిమెంట్ బికాస్ ద అటామిక్ మాస్ ఈస్ 4, నియాన్ ఈస్ 20, నియర్లీ 20. So they are lighter elements. They dissolved first. Okay, na, dissolved first. Leave the charcoal. They leave the charcoal. This gas mixture pumped into another Dewar flask. Okay, na. So from this first one we get 2 noble gases. What are the helium and neon? Lighter elements are extracted, and this gas mixture pumped into another. The remaining what are there? Krypton is there and xenon is there. Okay, na? Another Dewar flask containing charcoal kept cooled at minus 180 degrees. Agada 190 nunchi ikkada eginchiru minus 180 degrees. At this temperature, neon alone is absorbed. Only neon is absorbed at 180 degrees because when 180 degrees. See, at this temperature, neon is alone absorbed. The unabsorbed helium, then helium is pumped. Neon is dissolved by heating the charcoal. So next, the Dewar flask containing charcoal with absorbed argon is there, krypton is there, and xenon is there. Okay, there are 2 elements are, okay, 2 noble gases are pumped out. 2 noble gases are extracted. Remaining water, argon, xenon at minus 180 degrees is connected to another flask containing charcoal, same temperature, minus 190 degrees. Under these conditions, the higher number, okay, the lighter, under these conditions, lighter number of argon flows over the second flask where it is observed on the charcoal at minus 190 degrees. Argon is separated by warming the charcoal. Argon is separated out. The flask contains charcoal with adsorbed krypton is there and xenon is there. Warmed at minus 80 degrees. So to give krypton, krypton is absorbed. Okay, krypton is dissolved. Okay, now finally xenon is separated by further warming. So these are all the methods in the chart. Take the screenshot. This is the only you have to write in exam. It is easy. All of you. Take the screenshot, this one. Yes?
Again, sir.
Iskunara?
Yes, sir.
Yes, sir. Already having books.
Okay, so this is the okay book. Okay, this is the important one. Okay, now this is important. The question is how the noble gases isolation from Dewar's process, or how the noble gases isolation adsorption on charcoal method. Adsorption on charcoal method. So this is a flow chart. Okay, now this is the flow chart. See, separation of noble gases by adsorption on charcoal. See how the process is from noble gas mixture, activated charcoal at minus 190 and unadsorbed gas are pumped out. See, noble gas mixture, activated coconut charcoal at 190 degrees, minus 190. Unabsorbed gases are pumped out. Absorb only helium, neon, argon, krypton, xenon. The remaining any impurity gases, any impurities are there, just pumped out. Okay, then temperature raised minus 100 degrees, minus 100 degrees. So see, neon and helium is dissolved. 100 degrees దగ్గర neon and helium is dissolved. They went out. Okay, so pass into the charcoal, minus 180 degrees. Again 180 degrees. The decrease the temperature. Decrease the temperature. Neon is absorbed on charcoal at minus 180 degrees. Helium does not absorb, so it is removed. Okay, now helium is extracted. Okay, neon is absorbed on 180 degrees. Then temperature warm up. Okay, now the temperature is increased. The neon is dissolved. The neon also went out. This is one of the extraction of two elements. The remaining, see, charcoal at minus 100 degrees centigrade with argon, krypton, xenon mixture is there. Okay, now so connect these mixture into charcoal. Again, temperature decrease, minus 190 degrees, minus 190 degrees. See, argon flows out. Argon flowed out and absorbed and charcoal at minus 190 degrees. So these warm up, again warm up, and argon is dissolved. Argon is dissolved. So like this, these are the method. These are the method used for the adsorption on charcoal method. Very, very important and very, very important in zero group elements. Okay, na? Isolation and xenon fluoride. Okay, these are the two questions are covered in this lesson. Okay. See, properties of elements. So the properties, just atomic number is helium is 2, neon is 10, 18, 36, 54, 86. 2, 10, 18, 36, 54, 86. Helium. Okay, na? 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p6, 4d10, 5s2, 5p6, 4f14, 5d10, 6s2, 6p6. So lastly, finally, ns2, np6. Outer electronic configuration, ns2. General electronic configuration of zero group is ns2, np6, except helium. Helium is 1s2. Helium is 1s2. Okay. See the atomic mass. See the atomic mass. Atomic number 2. Exactly double. Exactly double or more than. So 2 atomic mass is 4. Neon 10, 20.18. And argon is 18, is 39.9 or extra. Okay. Krypton is 36, 83, 54, 131, 86, 222. Okay. See, these are the boiling points. Okay, na? And melting points. So no need to remember. See, they all are colorless and odorless gases. Noble gases are colorless and odorless. They are very slightly soluble in water. Slightly soluble in water. They are monoatomic gases. They do not exist as He2, Ne2, Ar2, Kr2. Only they are exist as monoatomic, as it is like this. As it is like this, like O, O2, N, N2, and H2. Like this does not exist, only exist as monoatomic, not diatomic gases. Okay, na? They are colorless and odorless. Their boiling point increase with increased atomic weight. Boiling point increase with atomic weight increase. They can be liquefied. Okay. So these are some important important one is the uses. Uses. This is also important question for short answer. See the noble gas uses. Okay, na? Helium is lighter than the non-inflammable and lighter element helium. It is used in meteorological balloons. You know that balloons, okay, na? Hydrogen balloon, helium balloons anevi flows air. Okay, helium oxygen mixture of helium and oxygen used for the deep sea divers, less soluble in blood than nitrogen. Okay, na? Sea lo deep sea divers, less soluble in blood than nitrogen. Okay, and it is employed to provide inert atmosphere to prevent oxidation of metal surface during the welding active metals. Then neon is used for the discharge tubes for illumination of decorative lighting. So neon lightings anevi hoardings untai. What are the hoarding means? In front of shopping malls and medicals, okay na, and road, okay na, they are representing whiteboard with color, okay na, they are representing as neon, okay na, neon bulb, okay na, decorative lightning and illumination, okay na, they are used as neon. Then neon gas gives an orange-red glow in discharge tube. Neon sign used for the advertising boards. Okay, na? Neon sign used for the advertising boards for the lightning. Okay, a mixture of neon with argon and mercury vapor discharge tube emits a blue light. Neon, argon with mercury emits blue light. Okay, so next, argon. Argon is used for the filament. Okay, now argon is used for the filament in electric bulbs, and radio valves and tubes. Radio valves and tubes. Okay, next, since it is inert and also prolongs the life of the device. Okay, now life of the device. It is also used for the Geiger counters. Okay, na? Geiger counters. And krypton and xenon are more efficient than argon is, okay na, incandescent, okay na, bulbs and Geiger counters. A krypton xenon mixture is used for photo flash tubes, instant photography. Okay na, you know that photo flashes. Okay na, you know that photo flashes, they are the mixture of krypton and xenon. Finally, radon is used for the treatment of cancer because it is a radioactive. Okay na, radon is radioactive element. It is used for the treatment of cancers. It is also used for the substitute of X-ray in the institution radiography. You know that X-ray. So this is the radon is used for the instant. Okay na, industrial radiography. Okay na, these are the uses of noble gas elements. Uses of noble gas element. Take the screenshot also. This one important. Uses of noble gases. Take screenshot. Okay, all of you taken screenshot. Okay, next one is structure of xenon fluorides. Structure of xenon fluoride. So only there are three structures are there. Xenon XeF2, XeF4, XeF6. Xenon tetrafluoride and xenon hexafluoride. So these are the only important xenon fluoride. Xenon combined with only fluorides. Okay, now these are the three questions important in this lesson. What are the uses of noble gases? SEM in see the structure, how the structure is. The method I take of molecule is interesting. The highly electronegative element fluorine is activate the xenon so that one or more pairs of electron in the outermost shell of noble gas element, depending upon the need for bond formation, are unpaired one electron from each pair promoted the d orbital. Okay, na sp3d2 or d2sp3, sp3d2 or sp3d3. They are shaped as sp3d2, sp3d3 hybridization based on Vesper theory. See shape of, okay na, shape of xenon fluoride. This is also important. XeF2, KrF2, XeF2, KrF2. Total electrons and 10 electron pairs are 5, and orientation of electron is trigonal bipyramidal. Okay na, lone pair is equatorial. Shape is linear. Okay na, this see the structures of XeF2 చూడండి ఇక్కడ కనిపిస్తున్న structures. All of you, are you listening or just put it aside for mobile
Yes,
phone?
sir.
Okay, see, these are the important. Okay, in this lesson we have to see how the hybridization is come. How the hybridization is come. See, XeF2. Okay, xenon is 8th group element. You know that 8th group element 1, 2, 3, 4, 5, 6, and 7, 8. Okay, na? Fluorine is only single bond. Okay, na? It bond only single sigma bond. The remaining, how many lone pairs are there? Number 1, number 2, number 3, 4, 5. 5 means, okay, na? 5 means sp3d. 5 means sp3d. sp3d hybridization. Okay, na? It sp3d hybridization. It is 3 lone pair containing. So it is in lone pair. Okay, na? It is structure is like this. F, 1 lone pair, 2 lone pair, 3 lone pair. This is the shape of the XeF2. XeF2. This is the shape of the XeF2. See how the shape is there. Xenon, 1 fluorine, 2 fluorine. How many lone pairs are there? 3 lone pairs. Okay, now this is the shape of the XeF2 with sp3d hybridization and linear. Okay, now in there exam lo sp3d hybridization and linear geometry. sp3d hybridization and linear geometry. See, ground state of xenon is ns2 np6. Okay, now ns2 np6. Okay, now excited state configuration is 1 electron is jumped into d orbital. 1 electron jumped into d orbital. So 1 s orbital, 3 p orbitals, and 1 d orbital. The hybridization of XeF2 is sp3d hybridization. sp3d hybridization. The shape of the molecule is linear. The shape of the molecule is linear. This is belongs to XeF2. Okay, then finally XeF4. XeF4. See, ground state is ns2 np6 d0. First excited state is 1 electron in d orbital. In this, 2 electrons jumped into 2 d orbitals. 2 electrons jumped into 2 d orbital. That's why 1 s orbital, 3 p orbitals, and 2 orbitals are involved. So XeF2 is sp3d2 hybridization. sp3d2 hybridization. So sp3d2 means, okay, now sp3d2, see the structure is xenon. How many fluorines are there? 4. Number 1, 2, and 3, and 4. There are 2 lone pairs there are two lone pair. The shape of the molecule is like this. Shape is square planar. Just note down XeF4 sp3d2 hybridization and structure. The shape of the molecule is square planar. Good పెట్టుకోండి, square planar. ఇదే రాయాల్సింది, ఓకేనా? sp3d2 square planar and shape. Square planar and shape. Right, enough. Okay. Next one. See, XeF6. XeF6. So, 6 FeF bonds are the molecule require 6 unpaired electron. 6 unpaired electron. The result form unpairing of the electron pair in the outer p orbital, promoting 3 electrons into the d orbital.
చాలా ఇట్లా జరుగుతుందా అని ఏం లేదు లేదా దీనికి అని కూడా అన్నాను. అంటే దానికి
okay, so see this sp3d2, okay na, there are 6, okay na, 6 required. See, in third excitement state, ground state is ns2 np6. First excitement 1 electron jump into d orbital, second excitement 2 electron, and third excitement 3 electrons. So 1 s orbital, 3 p orbital, 3 d orbital. So hybridization is sp3d2. sp3d2. It requires pentagonal bipyramidal. It requires pentagonal bipyramidal, but distortion, okay na, there are distortion. That's why this is a one lone pair, okay na, this is a one lone pair. It is distorted octahedral. Structure is distorted octahedral. sp3d3 hybridization and contain distorted octahedral. See the structure. This is xenon, 1 fluorine, second, third, fourth, 5 and 6. This is a lone pair. This is the lone pair, like this one. This lone pair is this. Okay na, this lone pair is this one. Okay. So total XeF2 linear. Just you write the structure and geometry. sp3d square planar, sp3d2 distorted octahedral, sp3d3. Simple. sp3d complete, huh? All of you taken screenshot.
So sir, these three structures are important.
Okay na? So these are the, they asked, okay na, write the explain about xenon fluorides. Okay na, xenon fluorides. I will tell, okay na, structure and hybridization and shape is enough. Structure, hybridization, shape of the molecule. It is xenon F2 is sp3d hybridization, linear shape. Okay, and XeF4 is sp3d2 hybridization and square planar shape, and XeF6 is sp3d3 hybridization and distorted octahedral shape. Okay, now you have to remember the shape, hybridization and structure of these three. Very, very important. In this lesson, they ask for uses of noble gases, xenon fluorides, and isolation of noble gases by adsorption and charcoal method. Very, very important. Dewar process also called, okay na, Dewar flask method or adsorption and charcoal, both are same. Okay. Okay. See, చూడండి. So last questions అడిగండి చూడండి. Last time, okay na, last time senior question, third sem lo already అడిగిండు. What is the isolation methods of adsorption and charcoal and noble gases అనే క్వశ్చన్ అడిగిండు. ఓకేనా, క్వశ్చన్ వచ్చింది ఆల్రెడీ, లాంగ్ క్వశ్చన్. ఓకే, I will display question paper. See, వినిపిస్తుందా? ఆల్ ఆఫ్ యూ.
No, sir.
ఆల్ ఆఫ్ యూ. సో ఇది స్ట్రక్ అయినట్టున్నది జూమ్ది. సో ద టైమ్ is also over. I will give important questions tomorrow, total from all blocks. Okay?
Yes,
And
sir.
last time question paper, I will explain last time question paper, how the questions are coming from these lessons, and important questions also from block 1, block 2, block 3, block 4. Okay? Tell me yes or no.
Yes, sir.
Okay, the Zoom up is పైకి వస్తలేదు. సో ద ఎండ్ ఓకే.
हो गई क्लास?
हाँ, हो गई, चलो निकलेंगे।
कहाँ मंदी खाने चल रहे? चलो चलो जाएंगे जल्दी।
थोड़ा बोल तो मन दिखा क्या हो रहा नहीं हो रहा।
चलो अपन दोनों आज बचे।
चलो फिर लीव करेंगे।